Okay, Anas, your problem's pretty simple to solve. So we'll talk about it. The broader lesson here is you need to think about, what we're actually measuring and if it makes sense what you're doing. Because basically, what you have here is you are running simulations on this plinth that, um, right, this thing here, which is inside and outside. Actually, let me turn off something outside down over here. I added some stuff. So you have one surface that's both inside and outside that you are running things like lead 4.1 studies on. And well, actually, this one is a daylight factor study, which is remember the exterior daylight factor. Which if we go to here and we go to so daylight availability is one of the general simulation categories, and then we have these different subroutines for daylight factor, which is what you chose for these first two. Uh, and by the way, this is an annual average. It's not just a time of year. You're thinking a point in time analysis, which is a different. That's point in time where we actually set a day and time. So you didn't. I don't think you ran any point in time. Well, you did here. Yeah. So you ran a point in time here, which had a specific day. So be clear on what you're doing, right? This is a daylight availability. It uses, and if you remember, daylight availability equals the illumination inside, so the lux inside divided by the lux outside, and that lux outside is defined by whatever sky model you choose. So this is one of a number that we could choose, and you could look up what those are. Right now, these are just different simulations of a sky around your, in your climate. And the idea is that so daylight factor is simply saying, okay, relative to the average sun outside, um, how much illumination do we have inside? So it's a percentage. And so you ran these and you were getting these really high percentages. And that's why it just seems, um, like just all yellow. If I move this up to 50%, then I can see something that's meaningful, which is that we have a lot of sun outside and relatively little inside. So the problem here is that you're averaging, um, because this is the average value for whatever surface we're looking at. Since we're averaging something that's completely exposed and completely inside, it's a meaningless number, right? It's the same thing here. We go to a glare study. Why are we studying one surface that is averaging? This is an average again. Exterior sun exposure. Remember, these are little pizza pies where these are views, and we're saying when we're looking in this direction, how many people would be uncomfortable 5% of the time, because we've got it set at 5%. So that's what this is going to be saying. And we're just basically saying, yeah, they're going to be, as far as glare goes, like if they're trying to look at a computer and they're sitting here looking any direction, they're going to be uncomfortable 5% of the time. I mean, yeah, 5% of the time, and it's going to be almost everybody, is what that's saying. Well, but that's really not helpful because now we're taking that average and bringing it inside. So again, if I came and made this 50%, um, or no, actually, it's not going to probably do anything because let's try something else, 75. Yeah, up here we're starting to get, some gradation, right? If we changed it to, this is an annual average, if we change it to a specific day, then yeah, we can start um, looking at different uh, patterns. So it could still be useful. In the summer, it's, we've got glare inside even over here at least most of the time. Anyway, so the main point I'm making is that we don't want to compare inside and outside space. We can do a glare study of outside if we want to, but we definitely want to have different work planes that we're testing. And the work plane is what is the surface on which we want to measure how much light there is. So let's go look at what I did. I created a, uh, let's see, I drew, I actually didn't even, I don't need my plinth anymore. Um, I'm gonna turn off my site just to make this simpler to look at, and the buildings also. I would put these all in one, folder. I mean, make them sub layers of a layer that said site, so you could turn it on and off really easily. Um, so I drew in a floor. Let me get out of here. I drew in a floor here and a surface that's offset. I just set it, offset it 2 feet so that I could then turn that into the work plane, which is this, and it's set, 30 inches above the ground. That's what I'm measuring the light on. And you just want to, so I have a separate work surface. I could separate this into different, zones in here if I wanted to look at different. So like maybe this is sort of an office area. This is a lounge area. I should separate it into whatever use areas that I want to distinguish. Um, and so what I did first is I did a test that was without, I didn't use the site at all. So let's just leave it off. Um, by the way, you have, so, you have you have angled glazing, but then you're open between the glazing. So that's kind of weird. That means that this open space is just going to let light in directly. So I think you need to make this a more complex facade if you're trying to angle that glass, and you'd have opaque surfaces in between the glass. Um, but anyway, so what we're saying here is that we've got 100% of our SDA. So SDA is the spatial daylight autonomy. If you zoomed in, you'd see that's 300 lux 50% of the time when people are in the building, let's say 9 to 5. Um, so that looks like there's no information there, but that's not true because if we go to the ASE, we see that we've actually got meaningful information, and that we've got way too much sun in here in certain parts of the room. But it's still not, just a flat zone like you had when we were here. Actually, here, and we went, I think actually, it's not that you did have gradations here, but since you were measuring one plate for this whole thing, you got an unrealistic number here and definitely here. Crazy, because this is the average for this whole surface. So if I come back up to what I just was showing us, and we look at this one space, now we have a more meaningful, still crazy amount of light. By the way, you can change this. So if I have this at 100, this value is the average. If I come and change this down here, this range, then I'm going to create a color range based on the inputs. I didn't change this at all, but I completely made this red. So if I go to 5,000, I've completely changed this graphic layout, but I haven't changed the actual average value. Um, so, you set this to what's meaningful for your project. You don't want to change this around probably for different simulations, but you want to find the range that works for your whole project. Um, 5,000 is crazy high. 3,000 is crazy high. I'm not going to, whatever. I'm just trying to make a point here. So now this is meaningful. And if I would then create separate um, work surfaces in these different rooms, then, or these different work areas, then I would get different values for each of them. And I could I could analyze what's going on. Um, the next thing I did is I turned on, the site. I probably have to put it on. It doesn't really matter because I remember with these, they have to have materials applied to them. So if I'm back here and I'm in materials, and you had, where's my site base? That's weird. I guess that's it. Yeah, so actually this surface does not have a material on it, so that might affect things. So you just got to be careful as to what you um, have applied surfaces to. Anything like these buildings, since they have this surface, now they're going to cause shading here, and it's going to change our outputs. So if I go back, and then what I'm saying here is that the second one, daylight autonomy test with site, I get a different value, right? So this is the effect. No site, 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 no site. So I can see that it's definitely working and that I have a comparison I can make. Um, and the same thing with the glare. I did a glare study. Oh, and by the way, I was playing around. You can also change this value. This we typically leave it at. Oh, keep going. I was messing around with how to to change the look here. Probably want to set this at 5% because that's the standard we're using. If you want to talk to me about that, I described it in class, but I'm not sure how many people got it. We're basically saying that how many, what percentage of people, let's just say that's one way of looking at this. They actually did a calculation, they did an equation to estimate glare, and then they calibrated it to actual people in several spaces. So this was a study that was done, and I'm not sure how many times it's been repeated or how accepted it is. But in Climate Studio, the metric is we can think of this as what's the percentage of people that will be uncomfortable at least 5% of the time, and if they're and so here we're at 53%, and that's the red. So we're saying wherever it's red, 53% of the people would be uncomfortable at least 5% of the time during the year, right? If we change this to a specific day, we completely change now we're saying that still the average is 53%, but on, you know, July, whatever date this is, August 3rd, people are not, they're totally happy over here. So you can attenuate it to a season. You can also look at different times of day. So this is really powerful stuff in here, right? Um, or you can also look at the annual. So you need to dig into these things. You're not getting the basics here, which, it's new. So but we're halfway through the semester. So I want you to really be grappling with this and trying to understand it. And so again, this was no site and then with the site, and that changes it. Um, that's the summary here. I think you see that I'm happy to do these videos for you. I'm not as good if we're like in class and you say, fix this for me, or I don't understand what's going on. And I'm looking at your little computer and I'm asking you to, I take your mouse over and I can't find the mouse or whatever on the screen. It's much better if I can just have the file and do a video like this for you. So that means you need to keep ahead. Send me these before class, if possible, so that I can maybe do them before class or at least look at it and we can talk about it in class. Maybe it'd be help other people to be going over these things. That's the idea. All right, so I think now you should be able to go back and adjust your assignment 4 to where you have meaningful outputs. If not, just ask me more questions and we'll keep this process going. All right, hope this helps.